So what I have developed here is the kind of start of this type of definition for the final. Um, the analysis, as I said, is key. I want it to be a fully functioning analytical model for you to be able to test the geometry out. So, and I've oversimplified it to be flat forms, and your form will be a little different because you're going to have you're not going to be all orthogonal. But anyway, what we have is a list of pretty much all of the variables that I'm going to have in the project. That's all these right here. I have my base footprint. That's this right here. So as I slide this back and forth, right, that's my base footprint. This brings it the other direction. My square foot range is listed here, and then I have wireless connectors for square foot low and square foot high. I also have the number of floors in my base, so I can switch down to a single-story base, two-story, or a three-story base level. So all of those things are variable. My height per floor is a standard number. My secondary footprint, so that's the second floor here. Okay, and then total number of floors is listed along with the floors in the second mass, which is a mathematical operator based off of where the secondary mass actually starts in terms of height. And then, of course, the offset of the secondary floor footprint, which is basically going to be its position around the model. Now, you don't have to have all of the floor. You could do it in Rhino and just draw a profile and then modify that in Rhino. I don't care how you do that part. It's the analysis part that matters. So as I slide this back and forth, if I put it into a condition where it's less than 50,000 square feet, okay, if it's less than 50,000 square feet, it registers a certain color. In this case, I chose red. Red is too low. Green is good, so that's between 50,000 and 55,000 square feet. And then orange is not good, it's too high, so it's over 55,000 square feet in this case. Okay, so I want to have that kind of functionality so that as you guys are developing your model, you can push and pull in order to get it to hit that sweet spot. Okay, so I'm going to just quickly show you part of the definition. So I kind of basically constructed mine off of rectangles and extrusions, but you may or may not have rectangles and extrusions. That part's up to you. So this is all variable. It's from this point on that it becomes rather static. Okay, these surfaces are the surfaces that I extrapolated from a bounding box, and that's what you see right. Not here. Where is it? Why isn't it showing? Oh, because that's just BREP. Sorry, the boundary volume. This right here. So these are the volumes that I use to extrapolate the floor slabs. And notice how I had to make a certain concession. I added 1 foot to the height of this, and I reduced this elevation by 1 foot. And that's because if I take my floor plate at exactly the level that this intersects, then I get 2 separate curves, and that's not good. So you need to have some play there. Anyway, so the way the dispatch situation works is what you've got to do is take all of these surfaces and then measure the area of them individually. So that's the area of each floor, and then do a mass addition. That gets you the actual square footage of the building. And then from that, you take that square foot low, right? This is where it's reoccurring, and you test whether or not this number is larger than the low limit. And that's going to give you a value out here that says true or false if it's lower. So then you use dispatch and you plug in your surfaces. Those are your floor plates. And if it's true, then path A is active. And it goes on to test whether or not it's smaller than 55. And if it's false, if it's lower than 50, it moves down to mesh color red. And that's what you see there. So turn that off, and I'll turn this off. So yeah, then it moves down to mesh color red. So that's what was happening when I moved my sliders down, and it had less. So anyway, if it's true, and it is above 50,000, you have to then be aware, and this is the part that hung me up because I was trying to measure just numbers immediately off of it, but I forgot that it's actually passing through the surfaces, not the numerical data. So you have to get the area again, mass addition again, and then test whether it's smaller than your high limit, square foot high, right there, 55,000. So again, if that's true, then it's going to dispatch again from the same surface, right? So, the same surface here, right? Your floor plates. If it's true, it's going to dispatch and go to the green. If it's false, it's going to dispatch and go to orange. Is that clear? So it's not all that difficult, and in fact, once you get to this level, all you have to do is list item and grab the vertical faces and just apply the same analysis but with different numbers. Okay, so basically you can almost carbon copy this directly, this whole section directly into your definition. So I expect you guys will be following along with the video on this one. Okay?